Okay, today we are going to review some important formulas, basically the distance, the midpoint, and the slope. So if you chose not to print out the notes, please make sure that you take out a piece of loose leaf paper. These formulas are going to be very important when we do our next unit, which is proving shapes in coordinate geometry. So the first formula we want to review is the distance formula. You use the distance formula when you want to prove that line segments are congruent or equal to each other. Now, the distance formula is this formula here that we all know. So if it says to find the length of line segment AB, given A is 3, -1, and B is 7, 1, we know that this is x1, y1, this is x2, y2. So the first thing we're going to do is write down the formula, which is x2 minus x1 squared plus y2 minus y1 squared. We're going to plug in what we know. Our x2 is 7, our x1 is 3, our y2 is 1, our y1 is -1. Now, for those of you that hate to do math in your head, you are more than welcome to type just this in the calculator. If you do that, if you type that in the calculator, you will get radical, and then the blue box, you get 20. The last step is to try to simplify. So if we're simplifying a radical 20, we're looking for two numbers that multiply to 20. Hopefully you pick 4 times 5. Which one of these is a perfect square? It's 2. So this distance is 2 radical 5. If we were finding the distance of another line segment, and it came out to be 2 radical 5 as well, we could say that those two line segments are congruent. The next formula that we want to review or go over is the midpoint formula. When you see the word midpoint, think middle. This is used to prove that line segments bisect each other. If they have the same midpoint, it means they bisect each other. So the example says, find the midpoint of segment CD if C is -2, 0 and D is -4, 7. Once again, this is x1, y1. This is x2, y2. So we're going to start by writing down the formula. Every time we write down the formula, we have a better chance of accidentally memorizing it. Second, we're going to plug in our values, -2 plus -4 over 2, and then 0 plus 7 over 2. Then we're going to use the calculator. If you want to do it in one shot, you need to put the top in parentheses. -2 plus -4 is -6. So we get -6 divided by 2. If you want to skip this step, again, use the parentheses button in the calculator and you'll get -3. For the second one, or the y values, we end up with 7 over 2, which we can leave as 7 over 2. If you want to, you can call it 3.5. Either way is fine. Again, if I found the midpoint of another line segment and it had the same midpoint as this, we could say that those segments bisect each other, which means they cut in half. So again, bisect means they cut each other in half. The third formula that we need to go over is slope, and that's usually used to tell if we have parallel or perpendicular lines. So if two lines have the same slope, they are parallel. If two lines have perpendicular slopes, they have negative reciprocal slopes. So once again, we're going to start with our points. So here we have x1, y1, x2, y2. It says find the slope of line EF. So again, start with the formula, y2 minus y1 over x2 minus x1. My y2 value is -3, my y1 is 7. My x2 is -8, my x1 is 6. We're going to do the math. -3 minus 7 is -10, and -8 minus 6 is -14. If you want to simplify that in the calculator, all you have to do is type in -10 divided by -14, then hit math, enter, enter, and it will reduce it to 5 over 7. That is the slope. If I found the slope of another line segment and it's the same, those lines would be parallel. If I found the slope of another line segment and it was flipped and negated, meaning -7/5, then the lines would be perpendicular. If you have any questions, please make sure that you write them down and either ask me next time you see me in class or email me.